Very good afternoon, all.
Good morning, sir.
So, what we have seen in previous class, we have discussed about the illumination. We have started it and we discussed some basic concept of the illumination. So, why there is a need to be study the illumination in engineering? That importance already have discussed, and what we will going to study in this unit. That also we have discussed in previous class. Okay, because the illumination we are using the electrical in energy utilization subject पढ़ना है उसमें what is the important of this illumination, because we are using the electrical energy as a source. And don't consider illumination means light. Illumination is the effect and light is the cause of illumination. That things we have discussed. So what is the importance of the light? There are generally two types of the lighting. We are considering natural light and artificial light. Natural light directly available from the sun, and artificial light that made by the man and the man-made, having some device sources that emit the energy, and it is a near about nature similar to the color of the natural light. Okay. Then we have seen the color. What is the wavelength for the different color that can be seen by the human eyes? So 4000 ampere angstrom unit to 7500 angstrom unit is the visible range of the human being. Is the visible range of the human being where we can see this light. That is visible range, and below that there is the ultraviolet, and above there is the infrared that we have seen. And then after that we have seen the relative sensitivity. What is the relative sensitivity? The sensitivity is the for which color the woman eye is most sensitive. Okay, so we have discussed the which color is more sensitive last lecture. Yes, can anybody? We have discussed that blue, yellow green, not blue green. Yellow green color having the more sensitivity, that is the sensitivity is maximum. This is for the which color? Yellow green color. Okay, even though there is a dim illumination, you can see that color completely. Don't think that the red color is a good illumination and or violet color. Okay, if we really check out in dim illumination condition, then yellow green having the good illumination, where we can see even though it is a dim illumination condition. Okay, clear this? Now, important terms used in the illumination engineering that we will see today. Important terms. Without these terms, we can't go in detail of illumination engineering. Okay. So start with the basic light. We have discussed 3 or 4 terms already. Just again, I have revised these terms. Light. How we define the light? The amount of radiant energy. It is defined as the radiant energy from the hot body that produce the visual sensation upon human eyes. Means we can see anything in front of you. That visual sensation produce, that is called the light, and usually it is expressed by Q. And what is the unit? Luminar, that discussed in previous class. And which is luminar? Lumen is the output of lamp. Okay, it is a unit of luminous flux. We will see luminous flux also. So luminar, which is equivalent to analogous to watt-hour. Watt-hour means kiska unit hai ye? What is the unit of watt-hour? Watt-hour किसका unit है? Unit of the energy. So which is light is equivalent to that lumen hour. In electrical terms we say watt-hour, power and time. So that is energy. Then luminous flux. Yes. What is the how you define the luminous flux? Yesterday we have discussed already. It is the total quantity of light energy. Total quantity of light energy emitted per second from a luminous body. Luminous body means which body? Which emit the light. कोई भी lamp consider करो that emit the. This is the lamp if you consider that emit the light. Okay. So total quantity of light energy emitted per second. Okay, that is the luminous flux. किससे represent करते हैं? It is represented symbol F and it is measured in lumen. What is the unit of luminous flux? Lumens or CDSR. CDSR, candela, steradian. Okay, we will discuss when we see candela. The unit of candela is the unit of this luminous intensity, and steradian is the unit of solid angle. Okay, that time we again discuss this CDSR about the unit of luminous flux. Okay, kaise aayi. Then luminous intensity. This is denoted by symbol F. This is by Q. Luminous intensity by I. Okay. Keep in mind that. So luminous intensity, how we define? It is a luminous intensity in any given direction is the luminous flux emitted by the source per unit solid angle. What is this? Luminous flux emitted by the source. Luminous flux emitted by the source per unit solid angle. So luminous flux F, F and solid angle is W, that is equal to I, that is equal to I. This is a luminous intensity and it is measured in, what is the unit? Candela. That is discovered by the scientist Candela. The name is given Candela. Unit of this I. Okay. Another unit, how you calculate another unit? What is the unit of this? What is this? F. F is the luminous flux. And what is the unit of luminous flux? Can anybody tell me? Luminous flux. Unit of luminous flux.
Lumen.
Lumen. And this solid angle, we will discuss in detail about the solid angle. Just keep in mind what solid angle. Lumen per solid angle का unit क्या है? Steradian. तो अपन इसको SR से लिखते हैं. Okay. So that's why here is a given lumen per steradian. Steradian. Clear this? Yes. Now here is a mention. See FW, luminous, lumen, steradian or candela. Candela is a symbol CD. Shortly अपन इसको ऐसे दिखाते CD से. Candela. Okay. Then again we have discussed what is the lumen. So lumen they directly derive from this formula. This lumen अभी जब अपने derive किया था, lumen is equal to candle power. Candela, candela को यहाँ पे candle power लिखा है, solid angle. Okay. Lumen, candela into solid angle CP W. Okay. Extra we already discussed. Okay. Total lumen out by the source in one candela is equal 4-5 lumen. अगर कोई भी source अगर all direction में energy emit करता है तो 3 dimension उसका कितना रहता है 4-5. Okay, ये भी अपन देखेंगे जब solid angle में डिटेल में बताऊंगा. Okay. So lumen is equal to candle power into solid angle. We derive from this formula. That is I equal to what? F. F is the lumen. उसका unit क्या है? F lumen. Solid angle. Steradian लिख ले. उससे ही और इसका यूनिट कैंडेला था इंटेंसिटी का कैंडेला CD. तो CD into solid angle यही से derive होता है it equal to lumen. Okay. From this formula we derive what formula for the lumen. Okay. So that things we have already discussed. Now candle power. Yesterday also this discussed. What is the candle power? Candle power again it is derived from the same formula of intensity. Candle power is the light radiating capacity of the source. What it tells us? Light radiating capacity of the source in a given direction. And how we define? Is the number of lumen given out by the source in unit solid angle. Number of lumen given out by the source in unit solid angle. Okay. अभी solid angle आप एक consider कर लो, एक angle ही है, यानी उतने इसमें energy emit करता है. Okay. तो ये यहाँ से ऐसा एक एंगल फॉर्म होता है. with respect to that area, तो solid angle बोलते हैं, वो डिटेल में अपन डिस्कस करेंगे. So number of lumen given out by the source in unit solid angle. Okay, कोई भी सोर्स है, सिंपल आपके घर का लैम्प कंसीडर करिए. Consider that lamp emit when you switch on the button and it emit the light. What you see there? As the light emit energy in only point direction, एक ही जगह एनर्जी देता है कि जहाँ आप बैठे हो वहां पे आपको इंटेंसिटी आती है क्या? It emit the light in overall direction. Okay, ऐसा नहीं है कि वो एक ही डायरेक्शन में दे रहा है, जहाँ आप बैठे हो वही इंटेंसिटी आपको दिख रहा है, बाकी जगह नहीं दे रहा. हाँ, that may be possible that in all the direction, in all the distances matter. Okay, in all directions, some direction there is a less intensity and some direction there is a more intensity. That may be possible. Okay, so whatever, when light is emitted and it fall on the surface, there is some angle from the source to the that intensity where it distributed, that is a solid angle. Okay, and वही अपन यहाँ पे देख रहे हैं, Cp is equal to lumen by solid angle. Now illumination. What is illumination? Already I have told you. When the light fall on any surface, that phenomenon is called as illumination, or it is the effect of light when light is fall on any surface. And that produce the effect on the surface and we can see the anything, and that effect is called as the illumination. Technically, how we define this? Number of lumen falling on the surface. If a light fall, Hori means what? Number of lumen, luminous flux. Luminous flux, the unit of luminous flux is lumen, and that number of lumen falling on the surface per unit area, it is denoted by the symbol E. Illumination किससे denote करते हैं? Illumination is number of lumen falling on the surface per unit area, that is a E, illumination. And what is the unit? What is the unit of this F? Lumen area, meter square. So lumen per meter square is the unit of this. Okay, and or you can say the lux. Another unit of this, standard unit of this illumination is lux. Symbol represents Lx, small a. Okay, so number of lumen falling on the surface per unit area, that is the illumination. Okay, all of you clear this? Yes.
Yes, sir.
Now, the formula important. This formula is very important to solve the numerical. Okay, E F by A. This is also important formula for solving the numerical. Okay. Now, mean horizontal candle power. Mean horizontal candle power. So what is this mean horizontal candle power? This all are the application of these three are the application of polar curve. Why using polar curve? वो पढ़ेंगे अपन आगे. We can easily calculate mean horizontal candle power MSCP, mean spherical candle power MSCP, and mean hemispherical candle power MHSCP. So these are all the application of polar curve. By using polar curve, we can calculate the intensity in any direction. We can calculate the intensity of any direction. So these are the application of the polar curve. So in this case also we calculate the intensity in particular direction. Okay, horizontal है तो horizontal plane में, spherical है तो all direction में, all plane में, hemispherical है तो above half circle and below half circle. So intensity can be calculated. So first of all, we see what is the mean horizontal candle power. Mean horizontal candle power. defined it. It is the defined as the mean of candle power in all direction. Mean of candle in all direction in horizontal plane containing the source of light. Mean of candle power in all direction in horizontal plane containing the source of light. This is the light which emit the energy. Okay, but what we consider it is a mean of candle power. Candle power किसका यूनिट था? Candle power से अपन क्या पता करते? Light emitting capacity of the lamp, light radiating capacity of the lamp, बराबर है? So one type it is the intensity है. So this horizontal plane, ये जो plane दिख रहा है आपको, ये प्लेन में जितनी भी अगर एनर्जी आएगी वो अपन इससे कैलकुलेट कर सकते हैं. मीन हेमिस्फेरिकल कैंडल पावर और दिस कैलकुलेट यूजिंग द पोलर कर्व. ओके, ये पोलर कर्व से कैलकुलेट कर सकते हैं. बट व्हाट वी गेट इट, हाउ वी डिफाइन दिस? बाय डेफिनेशन टेल दैट इट इज डिफाइंड एज द मीन ऑफ कैंडल पावर. मीन बोले तो एवरेज, मींस एवरेज ऑफ कैंडल पावर. Mean of candle power, average of candle power in all direction, but in which plane? Horizontal plane containing the source of light. Okay. Now mean spherical candle power. Mean spherical candle power. See definition. It is the defined as the mean of candle power in all direction. Mean of candle power in all direction and in all plane from the source of light. In all direction, but plane are considering the all the plane. Mean of candle power in all direction, in all plane. Consider this is source of lamp. Now we have three plane, three axis. X, this is x axis, y axis, and z axis. Okay, so light is emitted by the source of lamp in all plane or in all axis, all three axis. That is just mean spherical candle power. अगर स्पेयर है तो ऑल डायरेक्शन में आएगा. स्क्वायर का 3D क्या होता है? स्पेयर. ओके, तो ये टोटल एंगल बनाएगा एक, उस ऑल एंगल में लाइट इमिट करेगी. ओके, दैट इज अ मीन स्फेरिकल कैंडल पावर. So again, come to the definition. Mean spherical candle power, it is the defined the mean of candle power in all direction and in all plane from the source of light. ये लैम्प का सोर्स था, इससे सभी डायरेक्शन में लाइट ये एनर्जी इमिट होगी कंसीडर, और इन ऑल प्लेन. दैट इज मीन स्फेरिकल कैंडल. नाउ मीन हेमिस्फेरिकल कैंडल पावर. मीन हेमिस्फेरिकल, नॉट स्फेरिकल और नॉट हॉरिजॉन्टल कैंडल पावर. मीन हेमिस्फेरिकल कैंडल. हेमिस्फेयर क्या होता है? सर्कल है, सर्कल का हाफ पोर्शन, इसको ये 2D है और इसको 3D में बोला तो ये क्या हेमिस्फेरिकल हो गया. 3D में क्या रहता है? हेमिस्फेरिकल. ओके, सो सी इट इज द डिफाइंड एज द मीन ऑफ कैंडल पावर इन ऑल डायरेक्शन. ऑल डायरेक्शन, सभी में तो ऑल डायरेक्शन बोला, यहाँ पे भी बोला है दिस आल्सो इट इज कैंडल पावर इन ऑल डायरेक्शन बट इन हॉरिजॉन्टल प्लेन. यहाँ पे देखेंगे मीन ऑफ कैंडल पावर इन ऑल डायरेक्शन बट विच प्लेन? इन ऑल प्लेन. Again, mean of hemispherical candle power in all direction, but above or below the horizontal plane. Above ये half hemispherical, ये above or below the horizontal plane, passing to the source of light. Okay, so this is not easy to directly calculate this MSCP, MSCP or MHSCP. This can be calculated by using the polar curve. Okay. In upcoming class, we will see what is the polar curve. Now, reduction factor. What is the reduction factor? How we define the reduction factor? Yes. Reduction factor means source of light. Reduction factor of source of light, it defined as the ratio of mean spherical candle power MSCP to the its mean of candle power. दोनों का रेशियो कर देंगे तो आपको रिडक्शन फैक्टर मिलेगा. लैंप एफिशिएंसी, इफिशियंसी कोई भी इलेक्ट्रिकल में अगर मोटर की इफिशियंसी निकालते हैं तो इफिशियंसी कैसे निकालते हैं अपन? हाउ वी कैलकुलेट द इफिशियंसी? कैन एनीबॉडी टेल मी हाउ वी कैलकुलेट इफिशियंसी? यस, yes, can you tell me how we calculate efficiency? Efficiency कैसे कैलकुलेट करते हैं? सिंपल. हाउ कैलकुलेट efficiency?
Output upon input.
Output upon output upon input. So lamp, what is the output of lamp and what is the input of lamp? From this we can calculate the efficiency of lamp. Again, this is important terms because it is asked in the numerical also. So what is the output and input of lamp? What is the output? We are getting luminous flux. Lamp, whatever we are getting the output as a luminous flux. Or input carrying lamp, electrical lamp. What is the input to the electrical lamp? Power. Input power we are providing. So output is the luminous flux or lumen. जो भी बाहर lumen आते हैं या luminous flux. So the input is power input. So luminous flux to the power input and it is expressed in lumen per watt. It is expressed in lumen per watt. So clear lamp efficiency. Now specific consumption. What is specific consumption? अभी यहाँ पे लैम्प एफिशिएंसी का यूनिट क्या है? ल्यूमेन पर वाट है. ओके. स्पेसिफिक कंजम्पशन, इट इज डिफाइंड एज द रेशियो ऑफ द पावर इनपुट टू द एवरेज कैंडल पावर. जो भी पावर इनपुट रहता है और एवरेज कैंडल पावर, इट इज एक्सप्रेस इन वाट पर कैंडेला. ठीक है, रेशियो है तो कैंडल पावर का यूनिट कैंडेला है. दैट इनपुट पावर इज वाट, सो एक्सप्रेस इन टर्म्स ऑफ watt per candle. Now again important definition, the space to height ratio. इसके ऊपर भी न्यूमेरिकल में important terms है that we will in numerical it is difficult to calculate without knowing this formula. Space to height ratio. क्या होता है space to height ratio? In your home, have you seen there is a two lamp, there is some space between the two lamp. If the lamp is on ceiling, consider if the lamp is on ceiling and there is a distance, some distance in two lamp and it is above from some height from the working plane. Working plane is your earth surface and it is mounted at some height. That is the height. Space means space to height ratio. Space is the distance and height from the lamp, height of lamp from the working plane or working place. That is a height. So that's a space to height ratio. So it is defined as the ratio. This is like that, two lamps on the ceiling and this is earth surface. So this is distance of two lamp. How many distance of, and this one is earth surface. So what is the height? Okay. So horizontal distance between two adjacent lamp upon mounting height of the lamp above working plane. Above the working plane, that is the space to height ratio. Clear hai? This is clear? Space to height ratio.
Yes, sir.
Now utilization factor. What is utilization factor or coefficient of utilization? Total lumen reaching on the working plane utilization. Now see, if there is a source of lamp in our home that emit the light, so that emit light means to lumen, that emit the means number of lumen falling on the surface. Is the all the that lumen falling on the surface and it is useful? Number of lumen जितने निकल रहे होंगे लैम्प से, तो सभी अर्थ सरफेस पे आते हैं क्या, रीचिंग ऑन वर्किंग प्लेन पे? No, some maybe there is dust, dirt or anything, so some it is not possible to reach on the working plane. So total lumen reaching on the working plane to the lumen given out by the lamp, number of lumen given out by the lamp is more, and this is less. Okay, so it is less than unity. This factor is less than unity. Now maintenance factor. क्या होता है मेंटेनेंस फैक्टर? व्हाट इज मेंटेनेंस फैक्टर? So what happen if there is a light source, that emit the light? So what happen? Have you seen in your home light कि आपने ईयरली कंसीडर करते, एक साल में कभी वो लाइट निकाल के आपने कभी उसको क्लीन किया है? यस, हैव यू क्लीन दिस लैम्प? कभी क्लीन करते हो क्या आप? मुझे नहीं लगता यू क्लीन दिस लैम्प. जैसा रहता है वैसा ही रहता है वो लाइट. So what due to there is some dust accumulated on the surface of the lamp, dirt, smoke, and they emit the less light than they emit when they are new on or they are clean. Okay. Similarly, जो walls रहती है उस पे भी dust रहती है, ceiling है उस पे भी dust रहती है. So when the light is fall on that surface, it not reflect the same amount of light when it is clean. देखो, when lamp light is fall on the surface, it all get also reflected. Okay, but when there is a dirt, they are not clean. Lamp it is not clean. Then what happen? There is some means it reflect the less amount of light. Okay, so the maintenance factor is how defined? It is a ratio of the illumination under the normal working condition. Normal working condition means it may be there is a dust, dirt on the surface of the lamp. Normal चल रहा है जैसे चल रहा है वैसे. To the illumination when everything perfectly clean, when ceiling is clean, when wall is clean, and when lamp is clean, everything is perfectly clean. That is the illumination when everything is perfectly clean, and illumination under normal working condition. Normal working condition में illumination ज्यादा रहेगा कि everything perfectly clean condition में ज्यादा रहेगा? Yes. On this case illumination is more or this case? First or second? Yes. कौन सा केस में रहेगा? First or second? In second case everything is clean, The illumination is good. Walls clean, ceiling is clean, lamp is clean. So again, it is less than unity. Absorption factor. Next, absorption factor. In the place where the atmosphere is full of smoke fumes, such as in foundries, there is a possibility of absorption of light. There is a smoke or fumes जो रहता है, when the light is fall, that may be chance there is absorb the light. So total ratio of total lumen available after the absorption to the total lumen emitted by the source of light. The total lumen emitted by the source of light is always more. Total lumen available after the absorption to the total lumen emitted by the source of light, it is called the absorption factor. And its value is vary from the unity for the clean atmosphere and 0.5 for the foundries. And जहाँ पे clean रहेगा, there may be chance the unity, the light is reflected more, but when there is a foundries and there is a fumes, smoke, so that time there is a 0.5 that factor, adjustment factor. Okay. Now another important factor is reflection factor. So this define may be asked in the exam, the basics of this definition diagram. Just you have to do and write down the definition for the, there is a 4 or 5 definition is given and each for the 1 mark. Okay. So like the question asked in the topic, but this topic is this definition is important for understanding the next content of the subject, next unit of the subject. Okay. So what is the reflection factor? क्या होता है? What is reflection factor? Reflection. You might be studying 12th standard reflection. When the ray of lamp, we are considering single source, point source, and it light is fall on the surface. What happened? It reflected from the surface. It reflected from the surface. Plus bunch of angle of incident. Okay, if fall longer or reflected. With respect to the normal, we are considering normal reaction at center. So when the ray of light impinging on the surface means fall on the surface, it is reflected from the surface at an angle of incident. Okay, reflect incident. A certain portion of incident light is absorbed by the surface. कुछ portion of intense जो रहेगा light absorb करेगा surface. Okay. So ratio of the reflected light to the incident light, it is called as the reflection factor. Okay. Ratio of reflected light और ये incident light. ये अपन यहाँ से consider करते हैं. This is incident light. This is reflected light. यानी कम